Hi everyone, so let's have a look at the solutions to the 2023 HSC Extension 2 Maths paper. In this first video, we're going to look at the multiple choice. Question 1, which of the following is equal to, in brackets, a plus ib all cubed? Now, seriously, the easiest way to do this is just to expand out a plus ib all cubed, and we're just going to use binomial theorem. And so it's equal to a cubed plus 3 lots of a squared times ib plus 3 lots of a times ib all squared, and then plus ib all cubed, which is equal to a cubed plus 3a squared bi minus 3ab squared minus b cubed I. And if we have a look at which one that is, it is going to be a cubed take away 3ab squared, yep, plus I, no it's not a, it is c. Question 2, consider the following statement. If an animal is a herbivore, then it does not eat meat. Which of the following is the converse of this statement? Now remember, with the converse, we just switch these two around. So we want, if the animal does not eat meat, then the animal is a herbivore. And that is D. Question 3, a complex number z lies on the unit circle as shown in the complex plane below. Which of the following complex numbers is equal to the conjugate of z? Right, so we know graphically the conjugate of z is going to be a reflection in the x-axis, and this would be pi on 3 here. And probably the easiest way to do this is to write z in mod arg form. We know that the modulus is 1, and the argument is going to be this angle here, which is negative 2 pi on 3. Now we're not going to use that for part A, actually. Negative z, that's where we take, you can see here that x and y are both going to be negative numbers, and so negative z will mean both of them are positive numbers, so it would be up in here, negative z, so it's not A. Now B, we've got z squared, and z squared of course is equal to cis, and then we're going to have negative 4 pi over 3. And let's have a think about where that is. I'm just going to rub out some of this mess. So negative 4 pi and 3, we're going in a negative direction around to there and up into here. And in fact, that's going to be the answer, isn't it? Because that's 4 pi and 3 there. So yeah, the answer is B. Question 4, consider the following statement about real numbers. Whichever positive number r you pick, it is possible to find a number x greater than 1 such that ln x over x cubed is less than r. When this statement is written in formal language of proof, which of the following is obtained? Okay, whichever positive number r you pick. So that means for all positive numbers. It is possible to find means there exists a number x greater than 1 such that ln x over x cubed is less than r. Okay, where is that? That is C. Question 5. Which of the following is a true statement about the lines L1 and L2? And basically it's asking about parallel, not parallel, same line, do intersect, don't intersect. Let's start with parallel. Are these lines parallel? So we're going to look at these direction vectors and we're going to ask, is negative 1, 3, 1 a scalar multiple of 1, negative 3, negative 1? And the answer is yes, if k is equal to negative 1. So the lines are parallel. So we can knock out B and D. The next thing we've got to determine is if they are the same line. And to do that, we'll take this point, negative 1, 2, 5, and see if it lies on line L2. So let's start off by solving for the x coordinate. I'm just going to rub out that so you can see it. So 3, I'm just reading across the top here, 3 plus mu is equal to -1. So in other words, mu is equal to -4. All right, let's substitute mu in for the other two coordinates. -10 minus 3 times -4. Well, that is equal to, what is that? -10 plus 12 is equal to 2. Correct. And then finally for the z coordinate, 1 minus mu is equal to 1 take away -4, which is equal to 5, which is correct. And so because this point lies on L2, that L1 and L2 are the same line, and so the answer is A. Question 6. Which of the following functions does not describe simple harmonic motion? Now for simple harmonic motion, we want this relationship. The acceleration is equal to -n, x take away something or other, some constant. And the easiest way to do this is just to differentiate twice. So I'm going to start with A. There's quite a bit of work in this question. So our first derivative is going to be, if I'm differentiating cos squared, I've got 2 cos t times by negative sine t. Take away 2 cos 2t. And I'm just going to tidy that up. In fact, I'm going to rewrite that. It is negative sine 2t minus 2 cos 2t. And our second derivative is equal to -2 cos 2t plus 4 sine 2t. So the question is, can I write it in this form? So I'm going to bring out -2. That's equal to cos 2t take away 2 sine 2t. Have a look what we got here. Oh, we've got a squared. Okay, I'm going to rewrite that then as cos squared. So it's equal to -2. This is 2 cos squared t take away 1, take away 2 sine 2t. I like this. Is equal to -4 cos squared t take away sine 2t minus a half. And that there is x. So all of that work, it is not A. Let's try B. So in this case we've got first derivative is equal to 4 cos 4t minus 8 sine 2t. And our second derivative is equal to -16 sine 4t minus 16 cos 2t. Bringing out that -16, we have got sine 4t plus cos 2t. Is that x? Sine 4t plus, no it's not. Look at that 4 there. Okay, so which of the following functions does not describe simple harmonic motion? It is B. If I was actually doing this exam, I'd probably check C and D if I had the time, just to make sure that I haven't made an error. But the answer is B. Question 7. Which of the following statements about complex numbers is true? Now this is a tricky question. A says for all real numbers x, y, theta with x is not equal to 0, tan theta is equal to 1 on x implies that x plus iy is equal to r e to the I theta for some real number r. Well, that looks plausible. It's going to write plausible. B, for all non-zero complex numbers z1 and z2, arg z1 is equal to theta 1 and arg z2 is equal to theta 2 implies that arg z1 z2 is equal to theta 1 plus theta 2, where arg denotes the principal argument. This one's actually false. And it's because we could have, say, theta 1 is equal to pi on 2 and theta 2 is equal to 2 pi on 3. And then theta 1 plus theta 2 is going to be equal to what is that, 6, 3 pi plus 4, 7 pi on 6, which of course is not a principal argument because theta, this guy here, has to lie between negative pi and pi, and so B is out. C is out for the same reason. It's also false. For all real numbers R1, R2, theta 1, theta 2, R1, R2 greater than 0, we have R1 e to the I theta 1 is equal to R2 e to the I theta 2 implies R1 equals R2. That part's correct. And theta 1 is equal to theta 2, but this part is not correct because you can have the same complex number. Suppose you've got 2 e to the I pi on 3. That's actually going to be the same as 2 e to the I. I'm just going to add 2 pi to this. So the same thing, 3 6 is 7, 7 pi on 3. And yet we don't have theta 1 is equal to theta 2. And D, for all real numbers x, y, r theta with r greater than 0 and x is not equal to 0, x plus I1 iy is equal to r e to the I theta implies that theta is equal to arctan y over x. And that one also seems plausible. So which is it, A or D? So let's look more closely at A and D. Now the main difference that I can see, well, there's two differences. Here we're using tan theta and here we're using arctan. And arctan, of course, is defined between negative pi on 2 up to pi on 2, whereas tan theta is not. Sorry, theta is not in this case. The other difference, here it just says a real number r, so r doesn't have to be positive, and here r has to be positive. Let's have a look at A a little bit more closely. Suppose we have tan 5 pi on 4. Now, that is equal to 1. True? It's outside the bounds. Theta can only be in between negative pi on 2 and pi on 2, and that's outside. This is equal to, this could be written as 1 plus I, so this would imply, if you like, 1 plus I, which is equal to r, which is root 2, e to the I, in this case it would be pi on 4. And in that case, thetas don't match. So it's actually A that is incorrect, D is correct. Question 8. A shaded region on a complex plane is shown. Which relation best describes the region shaded on the complex plane? Now, if you have a look through these different options, we've got an absolute value of z take away I, and we've also got an absolute value of z take away 1. Now, this represents the distance that complex number z is from 0, I, which is that point there. And this represents the distance that z is from the point 1, 0, which is here. Now I'm just going to join those 2 points up. Maybe if I can draw a straight line. Sort of. Now, you see the edge of this circle here? That represents 1/3 along that interval. So if we have a look at that point there, just in there, where the circle meets that line, we could form a relation, the distance from that z is from I, and z from 1 there. And we could look at equality, for example. Now we could say that 2 lots of the distance that z is from I must be equal to the distance that z is from 1. So that point there where that intersects, that's the complex number z. True? So we want the 2 next to z take away I, and so that wipes out A and B. Now of course we haven't got equality because we've got a dotted line. We now need to figure out whether this is going to be greater than or less than. And so we need to choose another point. I'm going to rub all of that out. And I'm actually going to choose z being equal to 1. All right, so the distance that z is from 1 is equal to 0. And the distance that z is from this point here, 0i, is root 2. All right, 2 lots of root 2 is 2 root 2. And the distance that z is from 1 is 0. Here's my question. Is 2 root 2 greater than or less than 0? It's easy, isn't it? It's greater than 0. And that means our answer is D. Question 9. A particle travels along a curve from O to E in the xy plane as shown in the diagram. The position vector of the particle is r, its velocity is v, and its acceleration is a. While travelling from O to E, the particle is always slowing down. Which of the following is consistent with the motion of the particle? All right, so let's start here. The particle is always slowing down, which means that v and a must be opposite in direction. So what does that tell us about the dot product of v and a? So if they're travelling in opposite directions, it's kind of implying that the angle between them is obtuse. I don't know, does that make sense to you? Now we'll use this formula. V dot A is equal to the magnitude of V multiplied by the magnitude of A cos theta. And if we have got an obtuse angle here, then that means cos of an obtuse angle is negative. And so V dot A is going to be negative. So we can rule out C and A. Now let's talk about R dot V. So at any of these positions here, here's our position vector here, and our velocity vector is the direction that it's going. And can you see that they're always in a similar direction at each point? I'm making a mess here, but yeah, I think you get the idea. And so the angle between these two would be acute. And if the angle between them is acute, then cos theta would be positive, and so r dot v would be greater than or equal to 0. And that makes our answer D. Question 10. Consider any three-dimensional vectors A, B, and C that satisfy these conditions. Which of the following statements about the vectors is true? All right, quite a tricky question. So we'll start with A and see whether we can eliminate any. Again, we're using the dot product. So we're going to use this formula again. A dot B is equal to magnitude of A, magnitude of B, cos theta. Now, let's start with B dot C. So if B dot C is equal to 2, then this is equal to magnitude of B, magnitude of C, cos theta. And it says that we're assuming that B and C are unit vectors, which makes this equal to 1. And so cos theta is equal to 2, which is an impossibility. So it can't be that. Now let's try by the same reason. You can see that C dot A equaling 3 is also going to be impossible, because we will get magnitude of C, magnitude of A, cos theta. They're both equal to 1, and so cos theta is equal to 3, which is also an impossibility. So it can't be either of those. But what about this first one? And so if A and B are the unit vectors, then we have A dot B, which is equal to magnitude of A, magnitude of B, cos theta. And this is equal to 1. So in other words, A dot B is equal to cos theta, which is equal to 1. But the only solution to this is theta is equal to 0, which means, of course, A is equal to B. Now, having a look at these two that I've crossed out, then that means that we had B dot C is equal to 2, and we also had C dot A is equal to 3. Now, if A is equal to B, then A dot C is equal to 2, and C dot A is equal to 3, and they can't be equal to different things. All right, so it's not A. Let's keep going. Now I'm going to skip B and have a look at C. For any three-dimensional vector A, vectors B and C can be found so that A, B, and C satisfy these three conditions. Now this one's actually obviously not true, and I'll tell you why. Suppose that A is the 0 vector, and then 0 dot B would equal 0, wouldn't it? It's not equal to 1, and so this will contradict that first statement. So it's not C. And D, for all A, B and C satisfying the conditions, there exists R, S and T that are positive real numbers such that this is true. All right, so let's start with that. RA plus SB plus TC is equal to 0. Now we need to somehow get this involved. So let's take a dot product, both sides with A. And expanding out, we get R magnitude of A all squared plus S A dot B plus T A dot C, which must be equal to the 0 vector. Okay, we know A dot B is equal to 1, A dot C is equal to 3, so we have R magnitude of A all squared plus S plus 3T is equal to 0. And this can't be true because this is positive, R, S and T are positive, and something there has to be negative in order for it to equal 0. So D is out. Our answer is B. Okay, that's it. In our next video, we're going to cover questions 11, 12 and 13.